Hi folks, this is question 3. It just gives us a Venn diagram. We have to show that probability of A is equal to 4. We're just going to fill in all of the numbers that are in A. So 23, 18, 13 and 6, they're all in A. And we just put that over 240 because there's 240 in the whole Venn diagram. And that will give us 1 over 4. The probability of A union C. So we're going to take all of the things that are in A are in C. So that's 23, 18, 6, 13, 41, and 16. 61. 16, sorry. And then you just put all that over 240. And we're going to let it be equal to the probability of A. The probability of A is 1 over 4. We found that already. Up above, probability of C then is all of the things in C added together. All over 240. And then we're going to subtract what's in A intersecting C. So A intersecting C is the 13 and the 6. And if you put both of them into the calculator on both sides, it's 39 over 80. Right, so the rule for independent events is that the probability of A multiplied by the probability of B is equal to the probability of A and B together, or A intersecting B. So we just have to see if that's true. So we know that the probability of A up there was 1 over 4. We worked it out in the first part. Probability of B is, well, we have to add up all the B's together. So that's 18 plus 56 plus 6 plus 16 all over 240. And that actually gives us 2 over 5 in the calculator. So if we do a quarter multiplied by 2/5, that will give us 2 over 20, which is the same as 1 over 10. We just have to see, does the probability of A intersecting B equal the same thing? So A intersecting B is, well, A intersecting B is it's the 6 and the 18 together. So 18 plus 6 over 240, that's going to be 24 over 240. And you can see straight away that that is 1 over 10. So, yeah, they're independent. Right, so this part is conditional probability. So there's two ways it could happen. So the probability that first person had been to all three, and then multiplied by the probability that the second person had been to none. Okay, but it could also happen that the probability that the first person was at none, and then multiply that by the probability that the second person was at all three. So it could happen either way. And if you go back up to the diagram, the probability that the first person was at all three, that's just 6 out of 240, because that's in the middle. It's the intersection in the diagram. And then the probability that the second person is at none, well, that'll be out of 239 because there's one person chosen already. That's what conditional probability is. Because if you've chosen that for one person and they've been to all three, that's one person gone. So there's only 239 people left to choose from. And then that's just going to be the 67, the bit on the outside. And then probability of none, if we choose first that no people, so that would be 67 out of 240, because you're choosing them first. Multiply that by the probability of all three, then well then it's just out of 239 like before, and there's only six people. So we're going to get the answers to both of them. They're both going to be the same thing, okay? Because and then we're adding them together. That's 67 over 9560. And we'll get the same here, 67 over 9560. And we're just adding them two things together. Gives us 67 over 4780.